Our agenda for today is this. We are, oh sorry, not this one. This one, yes. So, introduction to derivatives. So I'm going to start today with the derivative of fx. What does it mean when someone say the derivative of fx, a function fx? Okay, sometimes you will see notation like this, dy dx, derivative of fx, because usually we define y is equal to fx. Sometimes also you will see something like this notation. Okay, and sometimes you're gonna see also people using the apostrophe to denote the first derivative. That is also fine. Sometimes I also use this as well. Okay, or this, something like that. They all means the same. They all means the derivative of y, or derivative of fx. Okay, so you will see a lot of this in textbooks and in probably some YouTube videos teaching calculus, but usually we are going to use this. In engineering, you will see something like this, y with a dot on top. Sometimes you will see y double dot. Okay, usually this this notation, nomenclature, is preserved for something that is with respect to time, a differentiation, a rate of change of y with respect to time, dy dt, for example. So anything with respect to time usually is denoted by dot or double dot on top of y, something like that. Okay, but in general we are going to look at these notations. Okay, usually sometimes people will have hard understanding when they just look at the equations and they don't know what it is. So this is the way to read it. Okay, so this d here, first you can say the rate of change, the rate of change of, okay, I'm talking about this here, dt, the rate of change of this quantity y, or f of x, this one right here, with respect to this, with respect to x. Okay. So if whenever you see something like this, d of fx dx, okay, you can read it, the rate of change of this quantity right here with respect to f is equal to, okay, the change in this quantity. Remember, f of x is the change of is the quantity of new minus old. Okay. Okay, divided by value h. What is h? I will show you visually later on. Divided by h, where h, when h is getting closer, or h gets closer, I think gets closer is better English. When h gets closer to 0. Okay, the rate of change of fx with respect to x equivalent to the limit of when the change in quantity, new and old, divided by h when h gets closer to 0. Okay, so let's understand the mathematical sentence that we are doing here. but if you are just writing it down, you can just write it down in the mathematical language: d f of x divided by dx, or ddx of fx, equivalent to limit of h approaching 0 of f of x plus h minus f of x divided by h. Okay, so what is it about? What is this? This is just sentences, mathematical language. Okay, so in order to understand that, I have prepared for you this diagram right here. Okay, look at this on the right hand side, left hand side here. Okay, let's say you have a function that is plotted on an xy graph. Okay, let's call that function plotted in blue fx. Okay, all right. So just now we have seen that fx here, f of x of h, and then f of x. What is it about? It refers to these two values here. Okay, all right. So f of x of h, that means the corresponding x value is x plus h. Okay, here. And then f of x here, the corresponding value is x, of course. Okay, and we see that p here is equal to x and fx. This is the coordinate of the point P, and this is the coordinate of point Q, x plus h, f of x plus h. Okay, these are the coordinates for P and Q. And what is trying to say here, if you see here as h approaching 0, what is actually h? H is actually the distance between P and Q in the x direction. Here, this h. So what the definition is saying, that what happened when h is approaching 0? What happened when Q gets closer and closer and closer to P? Okay, when the distance is almost 0. Well, not almost 0. When the distance h is approaching 0, what will happen? What would happen is you will get the slope of the tangent here, this thing. That means at P. That means the slope of this tangent here, this is what we call tangent, but right now this one is called the secant line. But when it approaches, when Q and P get really close together, h approaching 0, what will happen to the what is this actually? It will define as the slope of the tangent. So we will get something like this. We will get a straight line like that. Okay, it's not straight because I have unsteady hands, but as Q is approaching P, because h is approaching 0, it gets closer and closer and closer and closer. So this line right here, this one, sorry, okay, this line right here will be changing and changing, and until at the end when P and Q are really close together, h is approaching 0, then you will get a slope, the what we call the tangent line. This is what we call the tangent line. Okay, all right. The derivative here, what we're going to learn is, you can think of it in two ways. You can think of it as the rate of change of a function with respect to x. Okay, the rate of change of this with respect to this. Or you can think of it as the slope of tangent. Okay. So both definition will be used in engineering, whether you want to find the slope of a tangent or your rate of change. So that's the definition.